Use right-hand endpoints, estimate, using right-hand endpoints, estimate the area under the graph f of x equals x squared plus 4x plus 1 of the interval -3 to 2 using 5 equal rectangles. Okay, so the first thing to do here is to go to the x-axis or let's go to the curve and find those spots. So here we go. So it's the -3 dot, -2 dot, the -1 dot, the 0, the 1, the 2, and the 3. Oh, wait, we're only supposed to go to +2. That's only the last one. There we go. So those are the dots. And then for each of those dots, we should go straight to the curve, to the axis. So from the curve to the axis, from the curve to the x-axis, from the curve to the axis. Those three go down. These ones will go up because they're below the x-axis. So notice I took each of those spots on the curve from -3 to +2, found the dots, went to the x-axis, either up or down. Now, it says we want to produce right-hand input. We could have done right or left. They could ask us either one. That means we're going to start on the right and we're going to go straight. From the right straight and all the way down to the axis. That's our first rectangle. And now from the right straight and all the way down to the axis. From the right straight and just down to the axis right there. From the right straight into the axis. Whoops, that did not work. From the right straight to the axis. From the right straight to the axis. So it's always from the right. This is right-hand impulse. Straight into the axis, right? Straight to the axis, straight to the axis, and straight to the axis, straight to the axis. Okay, those are my rectangles. We got to find the area now of all five of those. To do that, we got to find the coordinates of the points. That's what we really need. So let's do those one at a time. I got to find the coordinates of this point right there. That's over 2. So I'm going to plug in 2, f of 2. 2 squared plus 4 times 2 plus 1. That's 4 plus 8, 12, 13. So that's over 2 up 13. And then we need that point. That's over 1. 1 squared plus 4 times 1 plus 1. And that's 6. 4, 5, 6. It's over 1 up 6. And we need the coordinates of that. I didn't do that so well. That point, that's over 0. So let's plug in f of 0. 0 squared plus 4 times 0 plus 1. That's just going to be 1 right there. So that's going to be 1. We got that. So that is 0, 1. Okay, and then this next dot down here, that's -1. Plug that in. -1 squared plus 4 times -1 plus 1. And that's going to be, what's that? 1 minus 4. It's 1, 2 minus 4 minus 2. I think it's right. Minus 4 plus 2. Yeah, minus 2. Okay, so that's back 1, down 2. And then there's this one, which is back 2. And plug that in. And that comes out as that 4 minus 8 plus 1 minus 4 minus 3, I think. Minus 3. Okay, so then what's the area of each of these boxes? Well, basically it's the height because each of these have a width of 1. Every one of these boxes has a width of 1. So it's just their height is going to determine their area. So then, this first box is going to have, and it comes up to 13. This next box comes up to 6. This box comes up to 1. This box goes down to -2, so it's negative area. Whenever boxes go below the x-axis, the y values below are negative. This box goes down to -3. So then our total, the area total, negative areas and positive, plus -2, plus 1, plus 6, plus 13, that's 19, 20 minus 5, yep, 15, as they said. And so there we go. So that's how we do these problems. So again, I started with all the dots on the curve, and then I went straight to the x-axis, straight to the x-axis, etc. Then I took the right edge straight over to the axis, straight over to the axis, etc. And then I found the heights of all the points. And so there we go.